Atomic Theory Science Lesson. Agenda. 1. Solid sphere model. 2. Plum pudding model. 3. Nuclear model. 4. Planetary mode. 5. Quantum model. Atomic theory timeline. 1803. Solid sphere. John Dalton. Atoms are dense and solid, with no internal structure or subatomic particles considered. 1897. Plum pudding. J.J. Thomson. Atoms are described as uniform, positively charged spheres with electrons embedded within them, similar to raisins in a pudding. 1911. Nuclear. Ernest Rutherford. Atom consists of a small, dense, positively charged nucleus at the center, with electrons orbiting around it, similar to planets orbiting around the Sun. 1913. Planetary. Niels Bohr. Electrons move in quantized, discrete energy levels around the nucleus and emit or absorb energy when transitioning between levels. 1920s. Quantum. Erwin Schrödinger. Electrons do not have definite orbits, but are described by wave functions that represent probability distributions of their locations. British chemist and physicist. Proposed the solid sphere model in the early 19th century. John Dalton. 1766 to 1844. Shifted from philosophical ideas to scientific theory. First atomic model based on experimental evidence and quantitative observations. Paved the way for the development of modern atomic theories. Solid sphere model. According to this theory, atoms are tiny balls that can't be broken and are all made of the same material. This theory helped explain how different chemicals mix together and what makes them different. Atomic theory. 1803. Couldn't explain differences in atomic mass within an element, isotopes. Didn't account for the presence of subatomic particles like protons, neutrons, and electrons. Couldn't explain the behavior of atoms in chemical reactions. Limitations. J.J. Thomson. 1856 to 1940. English physicist known for his work on the nature of electrons. Proposed the plum pudding model in the late 19th century. Discovered electrons as distinct particles. Shifted understanding from indivisible atom to subatomic particles. Paved the way for further exploration of atomic structure. Solid sphere model. According to this theory, atoms are tiny balls that can't be broken and are all made of the same material. This theory helped explain how different chemicals mix together and what makes them different. Atomic theory. 1803. Couldn't explain differences in atomic mass within an element, isotopes. Didn't account for the presence of subatomic particles like protons, neutrons, and electrons. Couldn't explain the behavior of atoms in chemical reactions. Limitations. Ernest Rutherford. 1871 to 1937. New Zealand-born physicist known for his contributions to nuclear physics. Introduced the nuclear model in the early 20th century. First model to propose a central, massive nucleus. Explained the behavior of positively charged alpha particles in the gold foil experiment. Laid the groundwork for understanding atomic structure and radioactivity. Atomic theory. 1911. Nuclear model. According to this theory, atoms have a nucleus with a positive charge and most of the mass, surrounded by electrons that orbit like planets. It explains why particles can pass through or bounce off atoms, and is the basis of our current understanding of atomic structure. Didn't explain the stability of the nucleus against electrostatic repulsion. Lacked details about electron orbits and energy levels. Didn't incorporate the principles of quantum mechanics. Limitations. Niels Bohr. 1885 to 1962. Danish physicist known for his pioneering work in atomic structure. Proposed the planetary model in the early 20th century. Explained atomic spectra with precision. Introduced the concept of quantized energy levels. Bridged classical physics with emerging quantum mechanics.